Hello, my name is Bennett Goldberg. I'm a professor of physics and director of STEM education initiatives at Boston University. I'm going to talk to you for a few minutes about critical thinking. We're using the concept of critical thinking to really frame two of the components of this active learning module, one on inquiry-based labs and one on problem-based learning. Both of them are grounded in this idea of critical thinking, so we'll just spend a few minutes talking about what critical thinking is. Critical thinking has been defined in 1987 by the National Council on Excellence in Critical Thinking as intellectually disciplined process of actively and skillfully conceptualizing, applying, analyzing, synthesizing, and/or evaluating information gathered from or generated by observation, experience, reflection, reasoning, or communication, all as a guide to belief and action. That's a long, complex definition of critical thinking, and we'll spend a few moments a little bit later on breaking it down. Critical thinking entails examination of structures. It entails examination of those structures or elements of thought implicit in so many elements of reasoning. It means, what is the purpose? What problems are we trying to solve? We address issues about what is the question? What are the assumptions that we make? How do we form research questions? What are a conceptual basis? What's our frame of reference? Critical thinking must incorporate all of that knowledge. We have to think about our empirical grounding. What evidence are we collecting? How are we thinking about that being generated? And then finally, we have to worry about the reasoning that takes us from our concepts, our basis of understanding, through looking at the data, the evidence in front of us, to the final implications and consequences of that action. And we also have to always incorporate objections from an alternative viewpoints. All of that creates a synthesis, if you will, based on our concepts and principles, the evidence and empirical basis, the reasoning, all the way to the conclusions that can affect actions and future predictions. Critical thinking encompasses a large family of thought processes and thought modes, not just the scientific thinking that we think about in STEM education, but also mathematical thinking, anthropological thinking, moral thinking, philosophical thinking. All of those are elements of this family that goes from concepts to evidence to conclusions to actions. Critical thinking has two primary components. The first is that there's a set of information and belief-generating processing skills. And the second, that there's a habit based on your intellectual commitment of using those skills to guide behavior. So again, it's the idea that I have a skill or you have a skill, and through that skill it can generate information and analysis processes, and that we in fact use that skill in reasoning to reach conclusions that can change behavior. So it's nice to see what critical thinking is not based on that definition. It is not the mere acquisition and retention of information alone, right? That's the lowest level of Bloom's taxonomy. It is not even the set of processing skills that you might have. And it is not even the use of those skills if you don't accept the results. So the critical thinking has those components of this set of skills of information gathering and processing and reasoning, and then the habits and behaviors to use them in a particular end. So critical thinking in STEM education is really around using evidence and data to guide conclusion formation and knowledge generation. I'm showing you two images here from Cynthia Brame's video that you'll see a little bit later on inquiry-based labs. These are students engaged in the process of scientific inquiry in an astronomy lab. They're looking at data about galaxies. They're forming research questions. They're examining the evidence. They're using that evidence to create conclusions. They're going through this inquiry cycle, all the way to the presentation and even the argumentation and refinement towards the end. So that's an excellent example in STEM education of critical thinking. The other place that critical thinking comes in is discovery-based laboratories. We use that a lot in my studio physics classroom, where we'll give students the opportunity to just explore observation space. What happens when I take a magnet and push it through a coil? What if I flip the north to the south and push it in again? What if I change the rate at which the magnet is entering the coil and exiting? What does the galvanometer attached to the coil measure? And allow that observation set to generate questions and have those questions then be asked through some simple experiments to lead to the conclusions that we want our students to get. The other place that we can use critical thinking to frame ideas around STEM education is in the space of problem-based learning. Problem-based learning is generally done in groups where students get together and face a larger challenge that is often grounded in our society, maybe a global challenge, but are well-defined problems that require a variety of skills to attack them. Students in problem-based learning have to be able to work together, have to be able to do observations, collect evidence, and then bring that evidence together in a conceptualized way. And so problem-based learning is another space that's a good example of critical thinking in STEM education classrooms.